I mean, the position and the pressure on the ankle are entries, just like us. We use the position of
physical
child
robot interaction.
To make it, keep equilibrium. So you take the position of the shoulder, on the ankle, on the pelvis, and you try to, for example, with the pressure on the ankle, you try to stabilize. If I push it,
and this is the researcher working
with
this robot.
Try to keep equilibrium. Yeah, the pelvis try to keep equilibrium like that. You know, you look at that, and he push as well.
So even though he's pushing the robot around, the robot will interact and try to get its own equilibrium. It's constantly working to keep its equilibrium.
Try to push.
This is especially the case when the robot is actually playing with a child. You might be a little bit more rough with the robot.
According to the frequency of the perturbation, and you react like that. And also, the compliance make him, and again, the compliance is used, I mean, as an interface. I take it and I drive the robot. And I mean the arm and the upper part of the body becomes just an interface for the robots. I mean, just like a little children. And our aim is to use it in learning system to learn gait and this kind of thing.
Snappy Sandy Underground.
All right, here's the picture.
About set done in the late 60s, really well drawn.
It's basically part of the head for animatronic. There are eyeballs in here.
And Snappy Sandy
and these eyes
wife is dropping LSD and
looking.
This is his job.
And that's the video of what the eyes are looking at.
Very funny story. Really well drawn. You find
now that one you got.
It would be like an exact.
So there's the eyes looking at me, the head, and there's the eyes looking at me. And this is a big version of that eyeball.
That one I don't know.
And the small version is in that piece of a head. And this is Mr. Lanny Smoot. He is actually the researcher who's done this. This is absolutely fascinating. Disney, he's from Disney. Disney's working on animatronic eyeballs that will actually move and simulate like real eyes. But the picture that we showed down here, the whole idea is that a person who lost an eye can now have a second eye put back in for the missing eye. It's a replacement. The glasses would have a magnet on the side and control the motion of that eye with a sensor on the other side. So the sensor on the one side sees which way that one eye is moving, and now the other eyeball, which is fake, moves in tandem.
Classic zoetropes, right, where it's the same thing over and over again. And in this one, we take audio input. So, if you guys want to grab it. All right. So you're the guy on the left. I'm this guy. Maybe you're the guy on the right. Sorry, we're
right. Your left, my right.
I think I'd get this down by now. So,
no big deal.
As we speak, as you can see, your little character will follow you. So, like what's up? That's you.
Oh, okay, so it's different.
Yeah, so we can have multiple characters from the same 8 frames of stuff.
Interesting.
And all we're doing is illuminating ping pong balls with LEDs. So you see I have this strobed LED, and as I speak, the pattern changes to select only the frames that we want to show you.
Right.
Because if it was illuminated all the time, it's just a big blur.
Right.
Now if I turn this thing off, excuse my reach.
And now we can see all the faces and all the... And that's it.
And then just marker on ping pong ball. The secret sauce is we have a rotary encoder on this track. It tells us how many degrees we've rotated. It's purely analog, we just get a sine wave out of it. And then we have voltage input, just the volume of what you're saying. And we match the two up when we're at a certain position. So there's no computer, there's no secret, whatever, it's just one analog circuit. Excuse me.
So the light only flashes on the shape it wants?
Yes. Okay. And the shape it wants is determined by how loud you speak.
Okay.
So,
and there's no computer control?
No, nothing.
This is not
it's just one analog circuit.
Yeah.
Yeah.
I mean, it looks sophisticated, but you're saying it's simplistic.
It's simplistic, and that's why it's sophisticated. Because it's using nothing, there's no computer, there's no anything. We're just looking at analog voltage levels and picking them out.
Wow.
And that's the simplest way to do it. It's awesome. Timing would actually be the pain.
Very interesting. Now, this is the Geek Bar. It's being sponsored by Disney, as you can see. Of course, you're going to have full conference access. And Disney has done all this stuff now outside of the bar, and then even inside. Seems this must be some new movie that Disney's working on, because it's part of the Geek Bar that created this whole setup right out front.